I need you to understand something that happened 17 days ago, something that makes no sense. Something that in my 42 years of studying celestial mechanics, I cannot explain through natural processes. On January 5th, at approximately 14:23 UTC, an object designated 3I/Atlas made what appears to be a course correction, not a gradual drift, not a slight deviation that accumulated over weeks. A correction, deliberate, precise, and here's what keeps me awake at night. It was completely unnecessary. Let me be clear about what I'm saying. This object, traveling through our solar system at roughly 31 kilometers per second, altered its trajectory by approximately 0.17 degrees. That might sound trivial. It's not. At interstellar velocities, even minute changes require enormous energy expenditure, and the trajectory it was on, it would have cleared Earth's orbit by a comfortable margin. No collision risk, no gravitational complications. Nothing that would naturally cause or require such an adjustment. I've spent the last 2 weeks trying to construct a natural explanation. I've consulted colleagues across 3 continents. I've reviewed the data hundreds of times, and every conventional explanation fails when confronted with the specifics of what happened. This is documented, this is real, and it's happening right now as we speak, because 3I/Atlas is still out there, moving along its new trajectory, and we have no idea why it changed course. Let me start with what we know for certain. 3I/Atlas was first detected in March of 24 by the Atlas Survey System in Hawaii. Standard detection, nothing unusual about the discovery itself. Within 48 hours, follow-up observations confirmed what the initial data suggested: this was an interstellar object. The third one we'd definitively identified, hence the designation 3I. Its velocity relative to the Sun was approximately 47 kilometers per second. That's unbound, that's escape velocity and then some. This object came from somewhere else, was passing through our solar system, and would continue into interstellar space on the other side. A visitor? A traveler. Like Oumuamua before it, like Borisov before that, for months, it behaved exactly as predicted. Its trajectory matched the models perfectly. We could plot its path months in advance with extraordinary precision. It was following a hyperbolic orbit, which is what you'd expect. No surprises, no anomalies, just a chunk of rock or ice from another star system, obeying the laws of physics as it passed through ours. Then on January 5th, everything changed. The first indication came from the Gemini North Observatory. They were conducting routine tracking observations when the position data didn't match the predicted coordinates. The discrepancy was small, just 14 arcseconds, but it was there, and it was consistent across multiple exposures taken over a 3-hour window. Initially, there was some discussion about whether this was an observational error, maybe atmospheric distortion, maybe instrument calibration issues. These things happen, so they requested confirmation from other facilities. Keck Observatory confirmed it 6 hours later. European Southern Observatory confirmed it 9 hours after that. The object was not where it was supposed to be, its trajectory had changed. Now, let me explain why this is extraordinary. When an object is moving through space, there are predictable forces that can alter its path. Gravity is the obvious one. If you pass near a massive body, a planet, the Sun, your trajectory bends. We can calculate this precisely. It's not mysterious. Outgassing is another mechanism. Comets do this all the time. As they heat up approaching the Sun, ice sublimates, creating jets of gas that can produce small thrust effects. This is what caused the slight acceleration observed in Oumuamua, though that case remains debated. Solar radiation pressure can also have an effect, particularly on small light objects with high surface area to mass ratios. Photons carry momentum. When they strike an object, they exert pressure. Over time, this can cause measurable changes in trajectory. These are the natural mechanisms. These are what we look for when an object's path deviates from predictions. The trajectory change of 3I/Atlas doesn't fit any of them. Let's eliminate them one by one, because this is important. This is where conventional explanations break down. Gravity first. For gravity to cause this trajectory change, 3I/Atlas would need to have passed near a massive object, but it didn't. On January 5th, it was approximately 2.7 astronomical units from the Sun. That's about 400 million kilometers, and nowhere near any planet. Jupiter was on the opposite side of the solar system, Saturn, Neptune, Uranus, all too far away to have any meaningful gravitational influence at that distance. I've run the calculations myself, multiple times. The gravitational perturbation from all solar system bodies at 3I/Atlas's position on that date would account for less than 0.001 degrees of trajectory change over the relevant time frame. The observed change was 0.17 degrees. That's 170 times larger than what gravity can explain. What about outgassing? This was my first serious hypothesis. Maybe 3I/Atlas is a comet. Maybe it started outgassing as it warmed up, producing thrust through expelled material, but there's a problem. Multiple problems actually. First, 3I/Atlas shows no coma, no tail, no spectroscopic evidence of sublimating volatiles. It's been observed extensively in multiple wavelengths. If it were outgassing, we'd see it, we'd detect the characteristic spectral lines of water vapor, carbon dioxide, carbon monoxide, something. We see nothing. Second, even if it were outgassing, the timing doesn't work. Outgassing-induced trajectory changes are gradual. They build up over days or weeks as material continuously vents from the surface. What happened to 3I/Atlas was sudden. The before and after trajectories are distinct. There's no smooth transition. It's like someone flipped a switch. Third, and this is crucial, the direction of the trajectory change is wrong for outgassing. When a comet outgasses, the thrust vector is generally radial, pointing away from the sun, because that's where the heating comes from. The trajectory change of 3I/Atlas has a tangential component. It's not pointing away from the sun, it's pointing somewhere else, somewhere specific. Solar radiation pressure? No. The object is too massive and too dense. To achieve a 0.17 degree trajectory change through solar radiation pressure alone would require 3I/Atlas to have the density of styrofoam and the surface area of a solar sail. Spectroscopic data suggests it's rocky or metallic. Radiation pressure is negligible, so we've eliminated the natural mechanisms. And that's where things get uncomfortable, because if it's not gravity, not outgassing, not radiation pressure, what's left? The only remaining explanation is thrust. Directed thrust, something that produced force in a specific direction for a specific duration, resulting in the observed trajectory change. I can hear the skepticism already. Thrust? From what? Where's the evidence of propulsion? Here's the thing. We wouldn't necessarily see it. If the thrust were produced by something we don't understand, something that doesn't involve visible exhaust plumes or thermal signatures, we might not detect it directly. We'd only see the effect, the change in trajectory, and that's exactly what we see. Let me give you the numbers, because numbers don't lie. To produce the observed trajectory change, 3I/Atlas would need to have experienced an acceleration of approximately 0.0003 meters per second squared, sustained for roughly 6 hours. That doesn't sound like much. It's not, it's tiny, but it's there. It's real, it's measurable, and it's unexplained. Now here's what makes this truly bizarre. Remember, I said the correction was unnecessary? Let me explain what I mean. We can reconstruct the trajectory 3I/Atlas was on before January 5th with high precision. We have months of observational data. We know where it was going, and here's what that trajectory would have done. It would have taken 3I/Atlas safely past Earth, past Mars, past the inner solar system entirely, with no close approaches to anything significant. The new trajectory, the one it's on now after the correction, is slightly different. It's still a hyperbolic escape trajectory, it's still leaving the solar system, but the exit vector has shifted, and here's the detail that haunts me. The shift is in the direction of a specific point in the sky, a point that corresponds to a star system approximately 24 light-years away. Now I need to be careful here. I need to be precise about what I'm claiming and what I'm not claiming. I am not saying 3I/Atlas is heading toward that star system. The angles involved are tiny, the uncertainties are large. Drawing a straight line from 3I/Atlas's current position through its velocity vector and extending it 24 light-years to see where it intersects. That's speculative. But I am saying this. The trajectory correction adjusted 3I/Atlas's path in a direction that, when extended, passes within 0.3 light-years of a specific G-type star. And that's interesting. It's interesting because if you wanted to make a small course correction to eventually reach a target light-years away, this is exactly how you'd do it. You'd make the correction early, when you're still relatively close to your departure point, because small angle changes early on translate to large position changes over interstellar distances. But that implies intention. That implies planning. That implies something I'm not comfortable asserting without extraordinary evidence. So let me tell you what happened next, because the story doesn't end with the trajectory change. 4 days after the correction was detected, NASA's Deep Space Network attempted to ping 3I/Atlas with a high-powered radar signal. This is standard practice with unusual objects. You bounce radio waves off them to get better ranging data, to refine trajectory estimates, to measure rotation rates. They received a return signal. That's normal. What's not normal is what else they received. For approximately 40 seconds after the primary radar return, the Deep Space Network detected a secondary signal. Faint, just above the noise threshold, but structured. It had a carrier frequency slightly offset from the transmitted radar pulse, and it showed what appeared to be phase modulation. I've seen the data. I've spoken to 3 people who were in the control room when it was received. They're not sure what to make of it. The official position is that it's some kind of echo effect, possibly a multipath return, bouncing off debris or surface irregularities. But echoes don't show phase modulation, echoes don't maintain coherence for 40 seconds, and echoes don't have carrier frequency offsets that appear to compensate for Doppler shift. I'm not saying it was a signal, I'm saying the data is anomalous. I'm saying it warrants further investigation. And that investigation isn't happening. Not publicly anyway, because here's where things get even stranger. On January 12th, 1 week after the trajectory correction was detected, NASA quietly updated the 3I/Atlas observing schedule. Observation time was reduced, several planned follow-up measurements were cancelled. The official explanation is resource allocation. Telescope time is precious, there are competing priorities. This happens all the time. Except it doesn't happen like this. Not with an object that's showing unexplained behavior. Not with something that just made an anomalous course correction. Usually that's when observation intensity increases, not decreases. I made some calls. Colleagues at JPL, friends at Ames Research Center, people I've worked with for decades, and the responses I got were evasive, not hostile, not dismissive, just careful, like they'd been told what not to say rather than what to say. One contact told me, off the record, that there had been discussions at high levels about whether 3I/Atlas warranted continued tracking. Discussions that involved people outside the usual scientific chain of command. When I asked what that meant, the conversation ended. I want to be absolutely clear. I'm not suggesting conspiracy. I'm not claiming cover-up. I'm reporting what I can verify. And what I can verify is that an interstellar object made an unexplained course correction, and the institutional response has been to quietly reduce attention rather than increase it. That's not how science normally works. When something doesn't make sense, we study it harder, not less. So where does this leave us? What are we supposed to make of this? I can think of 3 possibilities, none of them comfortable. The first possibility is that there's a natural explanation we haven't thought of yet, some mechanism we don't understand. Maybe 3I/Atlas has unusual internal structure that caused outgassing we couldn't detect. Maybe there's a gravitational effect we didn't account for. Maybe the data itself is somehow flawed and the trajectory change isn't real. I'd like to believe this, it's the most comfortable option. The problem is, I've spent 2 weeks trying to construct this explanation and I can't make it work. Every time I think I've found a plausible mechanism, the numbers don't match. The timeline doesn't fit. Something doesn't add up. The second possibility is that 3I/Atlas is not a natural object, that it's artificial, that the course correction was deliberate, produced by some form of propulsion system, executed for some reason we don't understand. This is the uncomfortable possibility, because if it's true, it means we've just watched something from another star system actively maneuver while passing through our solar system. It means we're not alone. It means someone else is out there, and they're capable of interstellar travel, and one of their objects just changed course for reasons we can't fathom. The third possibility is something in between. Maybe 3I/Atlas is natural, but it encountered something we didn't detect. Maybe there's something else out there, another object, something small, something we missed that interacted with it. Maybe the trajectory change is real, but the cause is something we haven't considered because we weren't looking for it. I don't know which of these is true. I can't prove any of them. What I can tell you is that something happened, something real, something documented across multiple independent observations, something that doesn't fit our models. And the response to that something has been silence. Not the silence of ignorance. We have the data, multiple institutions have analyzed it, there have been meetings, there have been discussions. This isn't unknown, it's the silence of uncertainty. Or caution, or perhaps something else. I've been thinking about what this means for us, for humanity, for how we understand our place in the universe. If 3I/Atlas is just a rock, if there's some natural explanation we've missed, then this is a fascinating puzzle, a scientific mystery, something that will eventually be solved and teach us something new about celestial mechanics, or material science, or some other field. But if it's not just a rock, if there's any truth to the possibility that this object made a deliberate course correction, then everything changes. Because that would mean for the first time in human history, we've observed something from beyond our solar system demonstrating intentional behavior, not just passing through, not just following the laws of physics, choosing, deciding, adjusting. That's profound, that's paradigm shifting. That changes everything about how we think about the universe and our place in it. And maybe that's why the silence, maybe that's why the reduced observation time, maybe that's why my colleagues sound careful when I ask questions. Because nobody knows what to do with this, nobody knows how to talk about it publicly, nobody wants to be the person who says, we think this might be artificial, without absolute proof, and nobody can get absolute proof without more observation, and more observation isn't happening. So we're stuck, suspended between possibilities, watching an object move away from us at 31 kilometers per second, following a trajectory it chose on January 5th, heading toward somewhere. Right now, as I speak to you, 3I/Atlas is approximately 3.4 astronomical units from the Sun. That's about 510 million kilometers. Every hour, it gets another 112,000 kilometers farther away. Every day, nearly 3 million kilometers more distant. Within a year, it'll be too faint for most ground-based telescopes to track reliably. Within 2 years, it'll be gone, lost in the darkness between stars, still out there, still traveling, still carrying whatever secrets it holds. We had a window, we had an opportunity, an object from another star system passed through ours, did something we can't explain, and we had maybe 6 months to study it intensively before it became too distant to observe in detail. And we're not taking that opportunity, for reasons I don't fully understand. We're letting it go. Maybe I'm wrong, maybe there's intensive classified observation happening that I'm not aware of. Maybe there are answers being worked out behind closed doors that will eventually be published. Maybe in 6 months or a year, we'll get a paper that explains everything, and I'll feel foolish for raising these concerns. I hope that's true. I genuinely do. But right now, in mid-January 2026, I'm an astronomer who's watched something extraordinary happen, and the response to that extraordinary event has been to turn away, to reduce attention, to move on. And I don't understand why. If you've listened this far, I want you to understand what I'm asking you to do. I'm not asking you to believe in aliens. I'm not asking you to accept any particular explanation. I'm asking you to care about the question. An object from another star system came through ours. It did something unexpected, something unexplained, and we're not pursuing it with the intensity it deserves. That should concern you, not because of what it might mean, but because of what it says about us, about how we respond to anomalies, about how we handle uncertainty, about whether we're really committed to following the evidence wherever it leads, or whether we're only comfortable with discoveries that fit our existing frameworks. Share this information, talk about it, ask questions, make it harder to ignore, because right now, 3I/Atlas is out there, moving, traveling, carrying its secrets away from us at 31 kilometers per second, and we're letting it go. In my 42 years studying the cosmos, I've learned that the universe doesn't give us many gifts. Interstellar objects passing through our solar system are rare. Ones that behave anomalously are rarer still. We've been given something here, a mystery, an opportunity, a question written across the sky in the movement of an object from somewhere else. And our response, so far, has been to look away. I don't know what 3I/Atlas is. I don't know why it changed course. I don't know where it came from or where it's truly going. But I know we should be trying harder to find out, and I know that time is running out. Thank you for listening. And if this matters to you, if you think these questions deserve answers, don't stay silent. The universe is speaking. We should be listening.